rational. Okay. So, I think the big picture here, what I really want to tell you is that yes, you do prepare questions like this, but you don't learn them off line by line. You should be able to write them in your own notation, etc. Okay, let's move on. Hard question for leaving cert. Okay, now we're into context and applications. So hopefully the whiteboard will be good here. So question 7, I need to have a little read of this myself. So the clothesline segment 01 is shown below. There's a picture here. The first 3 steps in the construction of the canter set, very interesting maths, is also shown. Step 1 removes the open middle third of the line segment, leaving 2 clothesline segments. Step 2, okay, it's written down here. Step 3 removes the middle third of the 4 remaining line. The process continues indefinitely forever, right? Set of points in line segment 01 that are not removed is called the canter set. Okay. Complete the table below to show the length of the line segment route at each step. Okay. Right. So it's saying, okay, on the first one, I'll draw it. So here's the interval 01. And 1/3 is removed. The middle. That means that 1/3 is taken out. Now the question would be what's left, and this is really the key of this question. And again, like, how do you see this? This is a pattern spotting thing. You can't really learn this, you can't really teach this, you just have to do loads of questions. So the important thing for me here is that what's left is 2/3. And what's going to be taken at the next thing is 1/3 of that. So if I go to the next one, it's telling me that the length of the line segments, it's going to be 1/3 of 2/3. And 1/3 by 2/3 is 2/9. And so you're going to have 2/3, and that's 6/9. Take away another 2/9, there's going to be 4/9 left. Okay. Then after that, so this is step 2 here. Step 1, step 2, and the question is going down step 5, 3, 4, and 5. Just classic pattern spotting. So now 1/3 of this is going to be taken, and 1/3 of that is 4/36. Well, that's the length that's left, and then 1/3 of that length is taken away. So we need to take away 4/36 from that. I'm kind of scrambling to my calculator, but it should be okay because this is multiply above and below by 4 is 16/36. Take one of these, it'll be 12/36. One-third. Okay. And then we take again 1/3 of this away, which would be 1/9. You take away 1/9 from 3/9, you get 2/9. Then you take 1/3 of this away, and that will be 2 by, oh, I'm an idiot. Yeah, I'm an idiot. So, my apologies, 1/3 of this is 4/27. So, maybe I will use the calculator a bit more. So 4/9 take away 4/27, 8/27, apologies. And then we're going to take 1/3 of that, which is going to be 8/81. And so take that away from that length. You're going to have 8/27, take away 8/81, 16/81. and then you're going to take a third of that. So I'm just going to multiply that by 1/3, and I get 16 over 243. And take that away from that. 16 over 81, take away 16 over 243, I get 32 over 243. The question though is, if your answer is fractions, the length of the line segments, 2 9ths, 4 over 27, 8 over 81. It's possible to probably look at the relationship between these. So I think it's possible that you multiply, if you're taking away a third, the amount left is a multiple of 2/3. So that's, these are powers of 2/3 actually. So yeah, good. Okay, right. So length removed is these numbers. Okay. Yeah, so pattern spotting, I can't, like, okay, obviously I made a stupid arithmetical slip, but I mean, what did I ever learn to do that? Nothing, just did loads of maths. Okay. Alright, let's see what's up next. Find the total length of all the line segments removed. I think we're looking at more more pattern spotting here. Okay. Find the total length of all the line segments removed from the initial line segment of length 1 unit after a finite number of steps in the process. Okay. So I think you need to spot a pattern here. So here you got 1. If you look at what's happening to the top, 1 by 2 by 2 by 2 by 2, and then the bottom 3 by 3 by 3 by 3 by 3. So each time 1/3 is being, the amount taken away is being multiplied by 1/3. So what have we got here? So the total length, okay, so the total length taken away, now we've got no notation here, so I'm going to call this Ln. It's equal to, so this is after n steps, I should use it then. So it's saying 1/3 plus 2 9ths plus 4 over 27 plus, okay, dot, 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 dot. And there's n terms. Now here is pattern spotting. You have to see that this is, you get from one term to the next by multiplying by 2/3. And the last one will be 1/3 by 2/3 to the power of n minus 1. Excuse me. It's a bit messy there. Okay. Now, that's actually probably answered the question in a way. It's 1/3 plus 1/3 by 2/3 plus 1/3 by 2/3 squared plus 1/3 plus 1/3 by 2/3 power of n minus 1. First, second, third, nth. But this is a geometric series. Geometric means you've got a sequence where you get from one term to the next by multiplying by a fixed constant. In this case, 2/3. And series means you're adding them up. And I think the formula for the sum of the first n terms, it's a times 1 minus r to the n divided by 1 minus r. Now that formula is in the tables. So we can actually do a little bit better here and say that ln, the total length taken away, is a, which is 1/3, the first term, times 1 minus 2/3 to the power of n, all divided by 1 minus 2/3. Now we can do a little bit more here because the bottom there is 1 minus 2/3, which is 1/3, and you've got 1/3 divided by 1/3 is 1. So you end up with 1 minus 2/3 all to the n, which, well, if I just get rid of these brackets, that's a lovely little answer. Okay. It's the total length. Now something really weird is going to happen here, by the way, but we'll drive on. So find the total length removed from the initial line segment after an infinite number of steps of the process. So basically the question is, as n goes to infinity, what's the total length taken away? And this is part 3. Well, if you keep multiplying 2/3 by 2/3 by 2/3 by 2/3, you're multiplying by smaller and smaller and smaller and smaller and smaller and smaller and smaller numbers. This bit goes to 0. If you go into your calculator and do 2/3 to the power of 100, you're going to get a very, very small number. This goes to 0. So I'm just going to write down the answer. L infinity is equal to 1. Okay. Now there's a really weird thing that I think they're going to hurt your brain here, but let's go. Okay, complete the table below to identify the endpoints labelled in the diagram. We're going to have to go back to the diagram and fill in this table. So what have I got? A, B, C, D, F. So I'm going back a few pages on the exam paper. Okay, A is 2/3, it's just right there. B is, okay, you have a look at it. You see you've got 1/3. The interval from 0 to 1/3 is split into 3. It's going to be 0/9, 1/9, 2/9, 3/9. B has to be 2/9. C similarly has to be 2/3, which is 4/9 plus a 9th, which is 5/9. What's next? D would be, excuse me, there's a small mistake here. So 6/9 of course is, sorry, 2/3 is 6/9, so this should be 7/9. And then the next one is 8/9. E, ugh. So down the bottom you got 0, 1/27, 2/27, 3/27. It's going to be B plus 1/27. B is 2/9, which is 6/27, plus 1 will be 7/27. And then F is 1 take away 1, 2, 27, so it's 25/27. Not sure what this is all in aid of. Again, it's just simple kind of pattern spotting. There's no teaching to be done there as such. Give a reason why this is a point in the Cantor set. Now this is probably one that's going to stump me if I'm quite honest with you. Okay. So I think what they're probably going for here, I'm going to have to pause it because otherwise it's just going to be me going, a what? A lot. Okay, so I figured out. It took me a couple of minutes, I won't lie. But I don't have the fully formed in my head. So probably what we have to do is go back to the picture of the first few forms of the Cantor set. So if you look at 0 and 1, that's the very start. Now the thing is, if they take out the middle third, and we can actually do this kind of dynamically, so this is the middle third. The important thing to realize is that once they take that out, these endpoints, similarly these endpoints are never going to be touched. So like they're always going to move into the middle and take out 1/3. And now these points are never going to be touched. And then they do it again. And after that, these endpoints will never be touched. So if we talk about 0 and 1, they were there at the very start. And then you had 1/3 and 2/3 were there after 2 iterations. Then we had 1/9 and the next number over, which was b, which is 2/9, that was in the second iteration, and then these two, this one here is c and d, I think. Yeah, so this is in the second iteration. And then the third iteration, they take these away, or these. Okay, and this one, yeah, there. And so if you look at the picture, as soon as you take away an interval, the endpoints of that interval are never taken away. Okay, now if I maybe just use some of this here. So A is here. May as well put them all in. B is here. C is over here. D is here. E is this one. And F is this one. Okay. And what we're going to show is that the number that they gave us is, we might have to go one more iteration down, we'll see. 20 over 81. Yeah, we're going to have to go one more step down. So 20 over 81 is approximately 0.246. So B here, 2/9. Is if it's about yeah, so this one here is like approximately 0.22. So what we're going to do is we're going to zoom in on this bit here. So the interval from B to E. So zoom in. B is 2/9. E is 7 over 27. Okay, and what we might do is we might write this in terms of 27s as well. So we'll write this as 6 over 27. And on this third iteration drawing, sure enough, that's this thing here, but we're going to take out the middle bit. And now we know that both these points are going to be there forever. So I know that these 2 points stay there forever. So this length here is 1 over 27. Therefore this length here is that divided by 3, which is 1 over 81. So I think what we're going to find is the number we're looking at here is 1/3 minus, that's here, minus 1/9 is, that's B, plus 1 over 27 is E, minus 1 over 81 is this point here. I'm going to call it G. So give a reason why this is a point in the Cantor set. G is an endpoint of one of the intervals in the fourth step. Is that easy? No. I've been trying to say in these videos that if the more maths you do, the more you see things. So for example, what I was doing earlier with the square roots, you know, that square root of 128 is square root of 2 by square root of 64. That is something that you'll see. But you probably will never see, the Cantor set has probably never come up in any exam question. It's kind of heavy enough maths. But the more maths you do, the better you would be at pattern spotting. So you do loads of questions. It's not the content that you're getting better, it's the pattern spotting. And also the confidence. You need a bit of confidence to do this. I mean, I paused the video, that was probably a lack of confidence, but I really didn't want to be and ahhing for ages. But I knew I'd be able to do it. You know, I haven't looked at these questions, I haven't looked at the solutions, just confident I'm going to do it. And the more maths you do, the more confident you will be. Is this answer written down perfectly? I don't think so. This is the reason, but there it is, we've managed to figure out what's going on here. The next question, funnily, is a bit easier. It's related to this question here. It says the limit of this series, probably should have included this as well, is a point in the Cantor set. Find the point. So the point is given as 1/3 minus 1/9 plus 1 over 27. They should have, in my opinion, put 1 over 81 and then done the dots. Plus dot dot dot. They're saying this is a point in the Cantor set. Again, you have to see the pattern, and the pattern is you get to the next number by multiplying by minus 1/3. Again, it's pattern spotting. Now this is an infinite geometric series, and the sum, so if A is the first term, the sum of an infinite geometric series is A over 1 minus R, and of course you need that the absolute value of R is less than 1, otherwise the terms are getting bigger and bigger and bigger and you're not getting what's called convergence. So the A here is 1/3 and the R is minus 1/3. So we end up with here this number here, which I'm going to call alpha.